Radio Frequency Systems is a world leader in the innovative design, manufacture, installation and project management of antenna and RF subsystems. RFS serves the telecommunications, broadcast and defence industries. We are represented on 6 continents with 9 manufacturing centres and sales offices. Specialising in broadband multi-channel broadcast systems, RFS designs and manufactures a world-leading range of antennas, including tailored panel arrays, RF switch frames, channel combiners and filters, and flexible air dielectric transmission lines. RFS Melbourne facility is the centre of excellence for the broadcast and defence product line, and the home of product line management, product development, sales, marketing, engineering, industrialisation and manufacture. The major passive RF components in a broadcast transmission system are the antenna, main feeder, combiners and/or filters, patch panels, rigid line and monitoring systems. Except for the main feeder, all of these components are manufactured by RFS at its Kilsyth facilities. Antenna systems range from panel arrays to cavity slot, super turnstile, log periodic, Yagi and dipole arrays. Some are built in large quantities for specific purposes, whilst many more are tailored systems as required for the broadcast industry. Broadcast and defence businesses are project managed by teams of broadcast systems engineers designing solutions for specific sites in a network. When new components, building blocks or entire technology platforms are required, we turn to our R&D teams who make use of sophisticated modelling software. Virtual prototypes can be constructed, which greatly shortens the product development cycle. RFS uses a number of software packages to model antennas, filters and transmission line components. Antenna system subcomponents are pressure tested, such as cable sets, power dividers, dipole and radiator assemblies and input assemblies. To ensure this is carried out efficiently and accurately, a large pressure testing tank is used that will enable very large components to be completely submerged. The cable de-reeling machine is set up to reel and de-reel all cables up to and including 4-inch. Cable is brought in from RFS Germany on bulk reels and then de-reeled to customer requirements. Cable jumpers and cable sets are also manufactured in Kilsyth. All HCA connector cable sets are pressure tested and high voltage tested, followed by a stringent set of inbuilt inspection regimes to ensure conformance to specification. RFS spins cavities used in its high-power circular waveguide filters and combiners in-house to ensure that critical dimensions and tolerances are maintained. It also ensures delivery schedules are controlled by RFS rather than an outside vendor. The welding area incorporates 5 separate weld bays set up for various operations. One weld bay is dedicated to silver soldering and brazing of power divider components and sub-assemblies. Another weld bay is set up for welding of rigid line components, which includes a dedicated fixture for welding of flanges and subsequent pressure testing. The remaining weld bays are multi-use and are primarily used for welding of stainless steel, invar, copper and brass. All weld bays are serviced by an overhead bridge crane to facilitate handling of heavy and large components. In broadcast, high-order filters are required to minimise interference into other bands of what are generally much higher powers from the broadcast transmission. As such, filters and combiners for the broadcast industry must be manufactured to exacting standards. Precision machining of components is absolutely critical, as are the processes of welding, electroplating and assembly. The paint shop includes a large dry filter spray painting booth. The entire paint shop area is enclosed and heated to provide a suitable dry environment for painting and cleaning. Adjacent to the paint booth is a series of baths used to clean and etch brass, copper and aluminium components, and also clean and process rigid line and associated components. The temperature cycling chamber can submit product to varying temperature ranging from -40 to 100 degrees Celsius. It can also be used for stabilising various filters prior to tuning and used for product evaluation and testing. RFS produces a range of 50 ohm rigid line components. Items for both unpressurised indoor systems and pressurised outdoor systems are available from 7/8 to 6/1/8 sizes. The room includes a dedicated stacker crane and purpose-built racking to ensure rigid line tubing is handled with minimal risk of damage. The tubing is stored in timber crates and is removed with the aid of a purpose-built vacuum lifter. The rigid line is then cut using the high-speed upsaw, which ensures accurate square and miter cutting as required. The Broadcast Tech Centre is the place where all filters, combiners, switch frames, connectors and many smaller antenna types come together. It is a clean, temperature-controlled assembly environment which ensures all items remain pure and free of contaminants. The main assembly area is serviced by a 500 kilogram capacity crane so that heavy items can be carefully and safely handled without risk of damage. Computer-aided tuning, or CAT, is utilised where required within the Tech Centre to streamline the tuning process of the highest order filters. The Broadcast Tech Centre also incorporates the recently established HCA connector assembly cell, which incorporates various state-of-the-art manufacturing concepts to ensure high quality and consistency of the RFS designed connectors. The northern end of the factory is dedicated to assembly of large, column-type antennas and arrays. They are also serviced by two 5-ton bridge cranes. The columns are assembled on purpose-built stands which also accommodate transport to and from the test tower. Assembly at the factory means that installation and tolerance issues are minimised on site, and the customer can be assured of the system's integrity on site. To avoid reflections, a test booth lined with non-reflective foam has been built for high-volume antennas like UHF panels. The RF signals radiated from the antennas are absorbed by the foam and not reflected back to the panel. The high ceiling on the booth is part of the design to ensure the reflections are at least 40 decibels down on the measured device under test. The booth is capable of holding 2 test jigs with 2 operators at a time. RFS has a dedicated in-house UHF 10 kilowatt DTV transmitter capable of being configured for all digital standards and even being split as a pair of separate channels. This is most beneficial for test and proof of adjacent channel filtering and combining. Validation of design is accomplished by rigorous electrical testing and, where required, complete power testing. RFS Kilsyth Australia has 2 antenna test ranges. The main test range is used for the testing of larger, fully assembled antenna arrays and has a turntable which is only capable of rotating antennas in azimuth. The turntable is capable of supporting antennas with a total weight of approximately 4 tonnes and to a total height of 12 metres. As the antenna under test is rotated, the amplitude and phase are recorded on a network analyzer and are used to confirm what the antenna radiation pattern is. The smaller range is used for testing smaller antennas and some of the building blocks that are used in the larger antenna systems. RFS's continued efforts in R&D and investments in its manufacturing, modelling and test facilities have allowed it to excel in the exciting field of broadcast. In 2009, RFS was recognised by an Academy Emmy Award for its pioneering work on adjacent channel combiners for TV broadcasting. Also in 2009, RFS Australia was inducted into the Victorian Manufacturing Hall of Fame for its manufacturing excellence. As an ISO-compliant organisation with cutting-edge engineering capabilities and talent unsurpassed within the industry, RFS is sure that its expanding global footprint and the number of satisfied customers will continue to grow for many years to come.